just keeps on changing on you, right? Now we're on to something totally new. We're not talking about redox anymore. We're talking about solutions and how you communicate or how you calculate how much stuff is in a solution. And if you're wrong, right, I mean, there's deathly consequences. If you say, oh, this stuff is only such and such of a concentration, it's really something else, ouch. And people get, sued and everything else all the time for this kind of thing. So it's important. And this is the only type. There's a lot of different ways to express the amount of something in a solution, right? And it's called concentration. There's a lot of different units you can use for concentration. We're only going to use one, and that's molarity. Okay, so it's used to describe concentration, the amount of something in solution. What's the word, Glory? Do you know? Instead of saying the amount of something in solution, we're supposed to say what? This is what's dissolved in water. It starts with an S. For example, you dissolve it in water. Water is the solvent. Solute. You're supposed to use the word solute. That's the chem speak. All right. What's the concentration of this solute? It could be salt. It could be whatever's dissolved in the water. But we're going to mess with these problems this way. We're going to use an equation. And for molarity, we're going to use big M. So big M stands for molarity. And our equation is our big M, or our molarity, is equal to what over what? Christina, did you get this out of the reading? What is molarity? Does anyone see it? Yeah. Moles all over, what was it? Liters. Okay. So we can put more words in there like Christina did. If you want to do that, go ahead. Big M is molarity. Moles of solute, whatever you're dissolving, all over liters of solution. So that's just the volume, right? Except they don't want milliliters. They want liters. It's fine. We can do that. We can mess with it. Okay. So that's one equation. Notice how that's an equation? How many variables are in that equation, Taylor? There's a little more than 2. Right? Because big M could be a variable, because that could be the one you're solving for. Or it could be the liters. Right? And then if it's a liters, see how there's 3 variables? You can solve for any one of 3 things up there. So that means in every single problem, Victoria, they're going to have to give you how many? And you're going to solve for the 3rd. They're going to give you 2. And I can bet you they're not, when they give you these 2, let's say they're going to give you the volume. I bet you they're not going to give it in liters. They're going to give it in what? Milliliters. Well, when you use this equation, you got to convert it into liters. And I bet you the moles of the solute, I bet you, Adelpho, they're not going to give it to you in moles. Oh, and so many moles of sodium chloride. No. They're going to say how many what of sodium chloride? Grams. I'll bet you, right? Oh, that'd be way too easy. There's no job security there. And it's not real life. No one masses out moles on a balance. You could, because everything's computerized. You could do it all for you, but they don't, right? It's kind of silly with all the technology we have, but they don't. They give you grams. Fine. So there is one equation. I'm giving you all the equations, but you're going to use this so much over the homework that you're going to have it. You're going to know it. One more equation, and we're going to get to it, but it's called a dilution problem. What's a dilution problem, Christian? What's a dilution problem? Oh, you're gonna have a big M of something. You're gonna have a solution. And dilution problem just means we're gonna add what to it? Water. More solvent would be the technical word. We're gonna add more solvent. So this thing becomes more dilute. And what's the new big M? What's the new molarity? That's all a dilution problem is. Okay? But it's very, very useful, because you only need 1 jar of this stuff on the shelf. And then you can make whatever concentration you want. It's just going to have to be less than what this one is. Right? And dilution. And we'll use the equation to get whatever solution we want, whatever concentration we want. Out of 1 jar. Okay, we can calculate it. It has to be more dilute because it's dilution, but that's the point. So what doesn't change during a dilution? All I'm doing is just adding the solvent, the water. So what doesn't change is, I guess I can't jump that high, but the moles of the solute. Because I'm not adding any solute. All I'm doing is changing the volume. So the amount of whatever we're interested in, the salt, for example, if that's your solute, that amount doesn't change. It's just the volume did. So it becomes more dilute. Okay. The equation. Anyone catch the equation in the reading? I don't have to use I's or ones. I don't remember. I like I's and F's. MiVi equals probably what? MfVf. The book might have used ones and twos, but the point is you have MI's. Right? I probably stands for initial, what you started out with. Final probably the final, right? Now this is supposed to be if this is, and these are, they're all dilution problems. Which M is bigger, MI or MF? It sounds weird, right? Dilution, you're adding solvent, but the concentration goes down, right? Because now you're dividing. There's more volume. There's more, so you have less of the solutes spread out over a bigger area. It's always more dilute. So, what's your stock solution? This 11.7 molar, right? That is going to be my MI. MF is always going to be the small ones. But notice how if you screw up, if you interchange them, it really doesn't matter. You get algebraically the same answer. So, but logically, it makes more sense if you start out recognizing, okay, MI is the stock. So let's try one of these. How would you prepare 100 mils, 0.59 molar blue? See, here's my 11.7 molar blue. Okay, and I want to make 100 mils. So I found a little flask that says 100 mils on it. It's got the little mark on there. And I want to make 0.59 molar blue. Okay. Yeah, we could, but we may not have to. Victoria said convert to liters. But first, before we jump into this equation, notice how, just kind of pretend you read this for the first time and you're wondering, what equation should I use? Because you know it has to be one of these. What's the big hint in telling you which equation you should use? You have two M's. That's exactly what I see. Now, there's probably more than one way, but Taylor and I see this exact same way. You have two big M's, right? So don't even mess with the top one. It has to be this one, right? If you see two big M's, you know it has to be that one. That, to me, really helps. Because when you start working these problems, how do you know which one to use? Two big M's, definitely dilution. Okay, how would you do it? So let's see if Victoria is right. Let's set up the equation. Do we need to convert to liters? MiVi equals MfVf. So what are we going to plug in for this stuff? The question really is, maybe before we do the algebra, the question really is, how much of this stuff do I take out of here, right? How much of this stuff do I take out of here, put in here, right, just drip it in, how much do I put in there, and then I add a bunch of water and fill it up to the mark, and I write 0.59 molar on it. So the question really isn't how much water I'm going to add, because I'm just going to stop adding when I get to the mark. The question is, how much of this stuff do I take? So I'm going to give you a little guide here. And because all the homework, they always say, how would you prepare? So you can't just do the algebra, which is what we're going to do. You also have to give an explanation. So I'm going to give you the explanation. And then you have to put in numbers. We're going to take Vi of Mi, take Vi of Mi. Now we're going to put numbers in for this stuff once we get it, but take Vi of Mi and dilute, that means just add water, to what volume? With our little equation, we're going to say dilute to MF's not the volume. Dilute to VF to get MF. Okay. To me, this is the simplest way to answer the question. It may not look that simple, but it is. We just got to put in the numbers. We can already put in a lot of the numbers. What's my MI? Everybody, you see it in the question? What's the MI? The initial concentration. It's got to be the 11.7. Okay? So you're not going to say MI. You have to say 11.7. And what's VF? Do you see it? 100 mils. So you're not going to say VF. You're going to say 100 mils. And what is my MF? 0.59 molar. Does everybody see that? Right? So we're going to take VI of 11.7 molar and dilute to 100 mils to get 0.59 molar. Just remember, take VI of MI and dilute to VF to get MF. That's how I do it. And it can make sense after you think about it for a while. But the point is, the only thing we have to figure out is VI. And how do you get it? It's the equation. Okay, now Victoria asked, we got to convert everything to liters. Can you see it? Do we need to convert everything to liters? Because if we use VF as 100 mils, what units would VI have to be in? It'd be in milliliters. If we do convert to liters, like Victoria said, convert to liters, no big deal. But then our units for VI will be in? Still in liters. So whatever units this stuff is in, that's what this stuff is going to be in. So, I mean, you don't, whether you give this answer in milliliters or liters, I would just do the easiest route. The easiest route is just leave it alone, right? So that's what I'm going to do. I'm just going to leave it alone. So I'm going to put the number for MI in. That's 11.7. The number, now VI I'm solving for. MF is 0.59. And VF was 100 milliliters. Okay, so my VI is going to be so many mils. Now, how do you get the VI? How do you get that number? First, do what first? Desiree, do what first? Well, no, just algebraic. Don't even worry. Well, the only reason why I put in the units is so you can see that they kind of cancel out. Yeah, I have to divide both sides by 11.7. So probably on the calculator, I would take these two, multiply them first, and then divide by 11.7. Do you see it? So multiply the 0.59 and the 100. Divide it by 11.7, and I'll have my answer. About 5. 5.04. You following me? Make sense? So what that means is, okay, take VI of MI and dilute to VF to get MF. So take VI of MI. VI is 5. So I'm going to take 5 mils of MI. All right. There. All right, there's my 5 mils. Put it in this guy. And don't spill. All right. And then I just want to fill it up to the mark. But I probably would do this, right? Make sure I get them all. Right? Otherwise, going through all that work, I don't get it all. And then I just keep squirting it in here until it gets up to that mark. Whoa, brought a bad jug here. There it goes. Right, until it gets up to the 100 mil mark. Make sense? Okay, and I just keep adding until it gets up to the mark, and I'm done. I should probably label it and write 0.59 molar, but that's the point. Take VI of MI and dilute to VF to get MF. So remember that, and you won't have any trouble answering the how would you prepare part. Because just giving the answer of VI isn't enough. You have to say the whole story. Okay. And how do we know to use this equation in the first place? 2 m's. Good point. Good deal. Okay. Let's take a look at this first question. EX1. Victoria, we are supposed to, let's see, if 48 grams of sodium chloride is dissolved in 250 mils of water, what is the concentration of NaCl in the solution? You have 2 options to solve all of these solution problems. Okay, well, yeah, okay, you're there, but which, I just want to get you to say first, which equation are you going to mess with? The first one, right? The first one, because she doesn't see what? 2 m's. So, I mean, Victoria's exactly right, but I like to follow logic. I like to follow every single question, approach it the exact same way every time, and let logic dictate what Victoria just said. In other words, what I'm trying to say is write down the equation first. Then it tells you what to do. It literally tells you what to do. Write down the equation first. Right? There's our equation. Recognize there's 3 variables. Which variable, Jacqueline, are we supposed to be solving for? Big M. Right? That's the one we want. Okay. Now Victoria said, she started to convert things into moles. She's exactly right, because look, we need it. We also need what? Liters. Right? So let the equation dictate what you got to do. Okay, so 48 grams of sodium chloride into moles, Janet. How do you do that? Yeah, you're looking up here. Good. What is it? Sodium's about 23 plus, that's about 50, is that 58? About 58.45. Does that sound right? So the molar mass of sodium chloride goes on the top or the bottom? Get the units to cancel. The bottom, right? The 58 point, what did I say? 35? Well, it is 45? Grams in a mole. All right, grams of sodium chloride in a mole of sodium chloride. Okay, so that part, we've got 48 divided by 58.45, around 0.82. Okay, so we've got the moles. Bianca, what would you do now? Okay, big M, 0.82 moles. But we still need see what we're missing, Bianca? We still need so how are you going to get the liters? Convert from milliliters to liters. Okay, let's see if Yesenia can tell us how to do that. We've got 250 mils. Bianca said get that into milliliters. Oh, she remembers. Millis 1,000. Does anyone know the quick trick to doing it? Move the decimal place over how many times? 3. But this is safer, right? Because you're not going to, no way you can screw up here. So that'll be 0.25 liters. So 0.82 divided by 0.25, about 3.28. And for molarity, you just write big M. Okay. So when they ask for concentration, you're after big M. Good deal. You bet? Does that make sense? Okay. Ashlyn, what equation would you use for this one? So MiVi equals MfVf? You always do MiVi equals MfVf if you see what? Two big M's. The problem needs to have two big M's. Like it needs to be, in other words, it needs to be at. I could give you a concentration and ask for a new concentration, because that's two. That would count as two big M's. But in here, they only list one. That 1.25 big M. Okay. So, Erica, we need to use this equation. Which one are we solving for? Erica, which one are we solving for? Yeah, liters. And then in the end, we got to convert it to milliliters. So we have to solve for the big liters. Okay? So Christina, what are we going to plug in for these two? Yeah, one of those. Yeah, did we do that once already? Oh, it was 48, son of a buck. Okay. 45, yeah, you're right. Convert that into moles. We said it was, there it is. We said it was 58.45. Good. Convert that into moles. About 0.77. Okay. Taylor. Now what? We have the moles.
Now we plug everything into the equation.
Yeah, so what are you going to put in for big M?
1.25.
1.25 big M equals 0.77 moles. All over my liters guy, right? So I'm going to solve for him. All right, if you want, instead of writing liters, you want to write V. That's fine, but this works for me. So how would you solve for this? Do you remember the trick? The diagonal story? Recognize what's on top and what's on bottom. It's like A over B equals C over D. And if you wanted to solve for D, you can only move along those diagonals, right? So the D has to go up where the A is. The A has to go where the D was, yeah. And then you got to move the B up where the C is. Okay, so how would you solve for volume then, for liters? What would you write? The liters has to go where? The liters has to go, it doesn't have to go up on the top? So liters has to go up here. Now where do you have to move the 1.25? Down the bottom, right? You see that? We're doing the exact same thing. We're just moving stuff along the diagonal. Move the liters up here, the 1.25 down there. So it would look like, if it looks better like that, do that. But a lot of times you don't see that part. But you end up with the liters, would be the 0.77 moles, all over the 1.25 big M. Right? That makes sense? Ashton, you see what I did? Okay. So 0.77 divided by 1.25. About 0.61, 0.62. So we got our liters, but we need to convert it into milliliters. How do you convert liters into milliliters, Adelpho? You don't sound confident. I wouldn't skip it. I wouldn't do it in your head. I would write it this way. Times, what's the ratio? How many liters is in a milliliter? Yeah. I wouldn't skip it. And then just do it on the calculator. It's too easy to screw up. Because you did all this work, you don't want to mess it up on the last step. Right? So that's what, 620? Right? Everybody follow? You try this one. Try this one. Or no. Let's do something really tough, right? It can't get any more complicated than this one. Let's do EX4. That is a tough one. If you can handle this one, man, you can handle anything the homework's going to throw at you. First, what type of equation do you have to use? The first one again, yeah, because there's only one mention of one concentration. Good. That's the first barrier. You recognize that. You recognize, have to use that first equation. Recognize what variable you're after. The question had to give you everything. It had to give you the other two. It has to. Is anyone not sure where to start? Let me help you out. Good. We're doing EX4. Yeah, and they want to know milliliters, so that means you're going to have to solve for this one again. That means we have to know that one, we have to know that one. So that one's easy, the 0.215. But this one, you got to convert that into moles.
Oh.
Right? Yeah, good. So then, yeah, then this guy goes up here. Yeah, that looks right. That looks right. And then get him into milliliters. Ooh, she has 97. What's the molar mass of H2SO4? What are you coming up with? 98. 98? They have 98. 2 hydrogens, a sulfur, and 4 oxygens. So somewhere around 98, I think. 97 point something. So you got to convert him into moles. Okay, you did. Now, yeah, there you go. It has to be that diagonal, the X. Then you can go from one side to the other, just move stuff along the diagonal, just like we did in the previous question. Yeah, you got it. And that's the number you're going to put in for the moles. Yeah, 0.949 divided by 98, whatever you get, that's what goes in for that. So about 0.0097 is what folks are getting for the moles. And then as a final answer, what did you get? Like 44? Around 45 mils? Did anybody else get about 45 mils as a final answer? Yeah? Okay. As a final answer, folks are getting around 45 mils. Do you need a calculator? You can use that one up there. Just grab one from my cart.
I have a question.
Yep.
But it's for this one. So, I don't know why this felt like easy to think of here. That was everyone.
Then, so recognize what's on top. Top, bottom. Top, bottom.
So, now do I multiply?
So now, to get this one, you have to move that one over, up to the top.
Mm-hmm.
So you didn't, to get this one, it'd be 0.85 times that.
Okay.
So it's kind of hard to see because you didn't line up that line with that line. Okay. It's around 45 mils, final answer. So all we've done are the first equation ones. You've got all these problems. Tell me which one or which ones are going to require the second equation, MiVi equals MfVf. So we have to pick from EX5, 6, and 7. Look at those, EX5, EX6, and EX7. Which ones, or which one, requires you to use MiVi equals MfVf? Take a look at every single one of those.
5.
I hear 5. Does everybody agree with 5? Yeah, look at that, 2 big M's. Definitely 5. Good. How about 6 and 7? How about 6? Let's take a look at 6. It has both. It has both, doesn't it? Because look, first you have to use this and this to get big M, right? And then you use the second sentence, and look at it. So it's 2 problems. This is both, right? So the first sentence, you have to use big M is moles over liters. And then the second sentence, that one is going to be MiVi equals MfVf. Now, you're really following this if you can see which M you're getting from the first sentence. Is it Mi or is it Mf? Which one is it? It's Mi. Yeah. So you are really getting Mi in EX6. Okay. Now we'll try one of these, but let's take a look at this one, EX7. What type of question is it? Same thing. You have to use the first sentence to get Mi, and the second one, MiVi equals MfVf. All right, let's try one. All right, let's try out. Oh, EX6 has more space, right? So let's use this one. Let's try this one. Let's try EX6. We got 5 minutes. See if we can knock it out. At least get started on it, so you have a good handle on how to do this. If you're not sure what I was talking about, just ask. Yep. No, you're getting the 500 mils into liters, so you can put that number down there. 1,000 mils in a liter. Yep. Now you have the bottom, so you can get MI. Good. Yeah, folks are getting like 4.2 moles. If you're getting like 4.2 moles, looks good, I think.
I have a problem figuring out which one.
Okay, you got it.
VI. So when I'm moving on to the next version.
Okay.
I thought that they would have been opposite. You know what I'm saying?
Yeah, I hear what you're saying. I think when it says to prepare, that's where you want to end up. So those are your Fs. So the 1 liter is the F. The 0.25 molar is the F. That's the only way I can tell.
Okay.
When they say, how would you prepare? And that's where you want to end up. Those are the Fs.
Okay.
So as an MI, Desiree got 8.4. What did you get, Yvette? 8.4. So around 8.4, I think people are getting for MI, for EX6. Right? That's what Taylor got too. So you should be using from that first sentence, you should be getting the concentration to be about 8.4, depending on your rounding, big M. And that's what you use for MI for the second sentence. Right? So that's going to be your big M. That's your big M. That's your MI. So then write the equation MiVi equals MfVf. Okay. So when it says, the part where it says, would you prepare, those are always your Fs. So how would you prepare this? That means you want to end up there. So there's your VF, 1 liter. There's your MF, 0.25. And then your MI is this. You just have to solve for VI. Then you have to say the words, take VI of MI, dilute to VF to get MF. But put in the numbers.
Am I supposed to leave it?
Oh, it has to be liters, right? Because big M is moles over liters. Good. So now, what volume do you want to end up? 1 liter, so put in 1 liter. And then you're going to solve for VI. And he'll be in liters. That's okay. Nothing wrong with that. 5 times 1 divided by 8.4. And then you'll have your VI. Okay, so we're about out of time, but come by. I'll be glad to help you out with this stuff.
Is it okay if you ended in liters?
Yeah, you can. Yeah, your final answer can be in liters, right? So you got, I'm not sure how many liters you got, but then put it in the sentence. Take VI of MI and dilute to VF to get MF, and just put in those numbers that you know for VI, MI, VF, and MF.